Once you've imported your model and applied your boundary conditions and then solved the system, you'll want to be able to visualize the results, and ParaView has a great range of tools to help you do that. So if we load our beam model now from this directory, it's just the same beam model. Then, as you might expect, this last button in the sequence is the one we want, which allows us to import our displacements. So I'm going to click that, and I've just placed all these files in that directory, so you've now got the displacement file here. We click OK, and that's all there is to it really. We click Apply, and as the displacements are read back in, the plugin is computing all the various strains. Now it computes, the displacements are given on a per node basis, but the strains are actually computed on a per voxel basis. So here's an example of what we can do. If we look at the first principal strain on our model, this is ParaView overlaying that on our model. You can see that there's an interesting artifact around that central point that wasn't allowed to move, but essentially it's a very simple model, and it gives us a very simple result. It's not very interesting because the colour mapping is just purely limited to what's happening up here, because most of the model is largely unaffected by the effect of this load. So the first thing to do is to have a look at the colour map editor, which is over here. We can look at the range by clicking on this, and you can see that there's really very little up in this area. I think it's maybe just this one point. So really the range that we're probably interested in is somewhere all in here, and there are various ways in ParaView to deal with that. So if we open the colour map editor, in the first place this blue to red view is a bit neutral, so we might want to swap to one of the presets, so if you click the little heart button, the blue to red rainbow is usually a bit more visually interesting. Nothing happens until you actually click in the screen, but still it's a bit limited in what it's actually telling us. So the first thing to try is you can add extra points in here. What we've got is everything, is all our data really is down here. So what we can do is we can click in this scale and create an extra point and sort of drag everything down so that there's a whole lot less blue going on, and that will that works as a quick kind of way of changing the range. But actually the effects are still rather strange, because actually the values that the range itself it's giving us isn't actually much good. So what you can actually do is use a left click to create that, and you can use a middle button click to delete it, and it takes us back to where we were. But just looking at this scale, we probably want to set a kind of limit really to maybe 0.12 or something, and ignore everything that's kind of happening around this point. So the thing to do there is to choose one of these buttons that resets to the whole range of data. If we choose this one, and instead of 0.2 here, we want to say stop it at 0.12, and then rescale to that, we should get somewhere a little bit nearer to what we actually want. One thing that we can do is use the clip filter to actually see what's happening inside, and as we mentioned before, the way that the clip works is to keep the side on where the arrow is pointing. So if I go ahead and click that, again, it's still a bit limited. So I think what I'll do is I'll bring this custom range down a little bit more, maybe even to 0.1. Maybe more still. Okay, starting to get there. I think it's a matter of trial and error, I'm afraid, to get the thing exactly like you might want. I think that's probably nearer to it now. So what's actually happening is everything above that value is getting clipped at kind of red, but I think that's starting to look like something that we might actually want. As you can see, it's kind of blocky because it's just defined on each cell. So one thing that we would probably want to do is use the cell to point data filter, which will compute. It interpolates across the nodes. And that's gone and applied that to our clip filter. It would probably have been better to have applied it to this in the first place. But there we are. We've now got a much smoother view of what this problem actually kind of looks like. And there are several ways to explore that a little bit further. Obviously, you might want to be interested in the third principal strain, and you might be interested in pure SED values. Again, you'll have to set up the scales because everything is, you know, that there are peak values going on here that are sort of distorting what's happening. At the moment, let me just get rid of the clip, and I'll add the cell to point data. It's here in the recent things again, to the whole model. So here we have these values. Displacement, obviously, on such a simple model is basically a very linear mapping. But there are a couple of other ways to look at that. One is to use the warp function, which will it knows immediately, since that displacement is the only vector that we've given the system, that displacement is the thing that we might want to warp our model by. And if I apply this, it seems to look quite extreme, and the model in itself is supposed to be 10 millimeters long, and this just looks too extreme to me. So I think I'll reset the scale factor to about half, and then if we compare that with our original model, that's what that kind of looks like. We can use a more interesting color mapping maybe to highlight that difference. So warping is a very useful way of visualizing the results, and you can apply clipping and things on the top of those to check that. Something else that you might want to try is using glyphs to show the vectors. Again, it's such a simple model that it's not going to be very dramatic here, but using glyphs, and again, since displacement is the only vector function we have here, that's all it's going to give us. But if we apply that, then it will show our glyphs. To maybe remove the original data, maybe we could color that by displacement anyway. But this will actually color by displacement magnitude, and that's what the glyphs are going to be set. It only supplies I think it chooses a sort of random number of glyphs to actually represent by using this, so up to a kind of maximum, so that it's a little bit more visible. And if you want to, you can sort of set the scale a bit more here, so maybe that's a bit high, 0.1 might be better. But usually the default is okay to get a first view. As I say, more interesting in other cases, I think, when you're trying to work out which way the mesh is actually warping on a more more interesting case. So something else that you probably would want to do in certain cases would be to look at these values like P1 in particular places. You might actually want to extract particular values. So if I drop the colour bar at the moment, one thing that we might want to do is to take a spreadsheet view and just select some points, and we can use the you can simplify what you're looking at here over in the spreadsheet by dropping quite a number of these parameters that probably of less interest. And block numbers and things like that. So it starts to become a little bit more readable. So you can actually select individual values using that kind of method, but it's still not very visual. So another way to look at this data is to use something like the plot over line function, which is actually it's this button here, I think, plot over line. And if I click that, it sort of randomly places the line that we might want to use in the scene. But in this case, let's say choose the Z-axis. That's the most obvious place to put it. So it's going to choose it next to this little point here. It might be more interesting if we actually placed it along the top edge. But we could use our spreadsheet function to work out the location of that coordinate and move our line. I think since we know that our model is radius a half, that we could move that ourselves anyway. But let's if I click the plot over line as it is, it tries to kind of draw everything that's available to it in that in these graphics. So we've got all these values, and you can obviously see they're all at different ranges. So if you move down the plot over line index, plotting material type in this case is nonsense. So we probably want to take out most of these values. If we were, let's say we're going to plot P1 and P3, so that starts to get to be a kind of more of an interesting graph, because we're so close to that kind of that point where the artifact occurs. It's actually of limited use. We might want to just adjust that axis point. So we probably want to move up in the y direction by, let's say, half. And yeah, the value sort of starts to get a little bit more interesting. You can use your scroll and wheelie mouse button to try and locate particular areas here. So that is kind of taking that that line now right across the top, and that's giving you another view of your data. So I think that's probably a good range of views on showing your data, and obviously be more interesting with different models. But that's basically it for this. Thank you.